Hi, welcome to Marker Board Videos. Today we're going to talk about Newton's second law of motion. If you watched the last video, you know we ended it by saying that acceleration was directly proportional to force and inversely proportional to mass, or proportional to 1 over mass. And so today we're going to talk a little bit more about that. So acceleration depends on how hard we push and how massive the object is that we're pushing. I gave you the example in the last video about two grocery carts. One is full of groceries, one is empty. If you push them both with the same force, the empty one, the less massive one, will accelerate more than the more massive one. You know that. That makes sense. You've lived that, so that's no big surprise. Acceleration then is directly proportional to net force divided by mass. Okay? So if we measure force in newtons, and we measure mass in kilograms, and acceleration is measured in meters per second squared, so that's a lot of ifs, then acceleration equals force divided by mass. That's a lot of ifs. You have to know that a newton is a kilogram meter per second squared. So kilogram meter per second squared, it makes sense. But those conditions have to be true. Now, can you use other units? Yeah, there's other units you can use, but in physics, these are the units we basically use. So just get used to using those. If you need the magic triangle, there it is. Force, mass, acceleration. Okay? There's your magic triangle. All right? So let's see what that looks like. If you double F, you're going to double A. If you double your force, you double your acceleration. If you double your mass, you have half the acceleration. Pretty easy so far. So let's do a couple of examples. We're going to do 2.5 examples. So here's the first example. A car has a mass of 1,000 kilograms. What's the acceleration produced by a force of 2,000 newtons? I always do my no want and formula grid. Thank you, Dr. Jeffrey Mallow, for teaching me that many years ago. I still use it. What I know goes in the first column, what I want goes in the second, and any formulas that relate what I know and what I want go in the third. So I know my mass is 1,000 kilograms. I know my force is 2,000 newtons. I'm looking for acceleration. Here's my formula. Acceleration equals force divided by mass. Acceleration is 2,000 newtons divided by 1,000 kilograms. Means my acceleration is 2 meters per second squared. Now earlier I said that if we double force, we double acceleration. Let's see if that's true. Let's double this force to 4,000 and see if our answer is double too. If the force is 4,000 newtons, what's the acceleration? Our mass stayed the same. Our force is 4,000. I'm looking for acceleration. My equation is the same. Acceleration is 4,000 newtons divided by 1,000 kilograms, or 4 meters per second squared, which is exactly double what we got before. So it is true, when we double the force, we double the acceleration. Now let's do another example. And this one's about planes. How much force, it's called thrust in a plane, must a 30,000 kilogram jet plane develop to achieve an acceleration of 1.5 meters per second squared? So now we're looking for force, so that's what we want. We know our mass and we know our acceleration. Acceleration is equal to force divided by mass. If I rearrange this equation and solve for F, I multiply both sides by m. We get F equals ma. Force is our mass times our acceleration due to gravity. 30,000 kilograms times 1.5 meters per second squared means our force is 35,000 newtons.